Okay, so the population distribution is assumed to be normal, and we're given a 10% significance level, and we have six butterflies, right? So the null hypothesis in this case is that the mean is 9.4. That is what our estimation of the population mean is, 9.4. And we're asked to investigate whether they are not growing quite as well as they could be. So we're investigating whether the mean is in fact less than 9.4. Okay, so what we know so far is the sample mean. So we have a sample size of 6. We have 6 different butterflies. So we just add them up, and then divide that by 6, and you should get 9.22. This is in 3 significant figures. And then we also need to work out the estimator for the population variance. Because we do not have the population variance, so we need to estimate what the variance is for the population. So we are doing S squared here. So S squared is actually 1 over n minus 1, sum of x squared minus nx bar squared. Okay, so in this case, if you work this out correctly, you should get, let's see, S should be 0.462. Again, this is in 3 significant figures. All right, so once you've done that, you can work out the test statistic. So what exactly is this test statistic? Well, imagine if you were to draw out the t-distribution curve. All right, so the middle part is going to be 0. So anything to the left of that is going to be negative, anything to the right is going to be positive. And we're investigating whether it's less than 9.4. So the mean is actually going to be somewhere in the middle. So this is actually after you have standardized it. And that's what we're going to do with the test statistic in a bit. So let me just write it out. So the test statistic is actually x bar minus mu divided by s over root n. So you can see this is very similar to how we do standardization for the z-score of the normal distribution. Mean and then sigma, right? It's very similar. So when you go through this process, the mean is going to be set to 0 for the new distribution. Okay, so since we're investigating whether it's less than 10%, that means it kind of looks like that. And then this is the rejection region, and this rejection region is 10%. And this region here is 90%. Okay, so we need to work out what this critical value is. So I'm going to call this TC. And we need to work out where our T is. So our T could be here, in which case we have to accept the null hypothesis. If our T is in here, then we can reject our null hypothesis. So we have sufficient evidence to reject, because it's very unlikely that our sample mean would be so far out from the supposed population mean. Okay, so how do I work out TC? Well, to do that, we need to work out what P is. That's the percentile. So in this case, you can see there's 90% over here, right? So basically the percentile is, okay, maybe I shouldn't explain it that way. Hang on, I'll get rid of this. So if you look at our MF19 list of formula table here, you see that the way it's defined, or the way the table has been calculated, is it's based off the area coming in from the left. But if you are trying to find this TC here, it's actually kind of equivalent to finding this thing right here. So let's say this is 0, and this is, I'll call this negative TC, okay? So if we can work out, we know this is actually 90%, right? So if we can work out what the negative TC value is from this graph, we can actually infer what TC is, which is what we are trying to find. So how do I find negative TC? Well, we know that this is actually 90%. So our P, which is the percentile, is going to be 90%. So 0.90. Okay. And next up, or alternatively, you could also do 1 minus our significance level, which is 0.90. So that's another way of doing it. Okay. Then next up, we need to work out the degrees of freedom, gamma, which is basically n minus 1. So we have 6 butterflies, so that's 5. So now looking at our MF19 table here, you see that when the degrees of freedom is 5 and our percentile is 0.9, our critical value is 1.476. So what this tells us is that negative TC, this guy over here, is actually 1.476. So what this means is TC is actually negative 1.476. Okay, so all done. So now we need to work out what T is. So T is going to be 9.22 something minus our mean, which is 9.4, divided by 0.462 something divided by square root of 6. So one thing to note here is you should always use the unrounded values of the sample mean and your unbiased estimator of the standard deviation over here instead of the rounded values over here, because then you'll be rounding off 3 times, which would give you a significant error at the end. So use the unrounded values. So if you work this out correctly, you should get negative 0.9715. So where is negative 0.9715? That's going to be somewhere right here. Yeah, negative 0.9715, because our TC is actually negative 1.476. And as you can see, our test statistic T is in the acceptance region. It's not in the rejection region. So you can say since T is greater than TC, we do not have sufficient evidence to reject our null hypothesis H0. And there you go. That's it.